So glad you stopped by. So anyway, as I was saying, Robert, Robbie, Bobby, Bob, let's go with that. Try to make these videos somewhat entertaining, for the students. Really do, while at the same time trying to get information in there they need in order to learn the math and be able to do the assignments.
Oh, that's really cool. I appreciate the kind of complexity of it.
So back when you were in high school, you were a big fan of math and math class, right?
Sure.
Yeah, that's cool, man. I was talking with our principal, Dr. Guthrie, this week. You did know that he graduated with his doctorate, right?
Yeah, he's becoming a better guy.
Yeah, we were talking about, we've got all these lessons out there, all these great lessons, and some students they're skipping the videos and just going straight to the assignments and trying to do the assignments without ever learning the lesson. I mean, that wasn't you in school, right? You were one of the ones that paid attention to the lesson, right?
Sure.
Yeah, some of the students, they're really sharp in math, and they don't have a lot of problem doing that. If there's something they don't understand, they look it up on the internet, and they seem to do okay. But there's a lot of these students that, man, they have no idea what's going on. You can tell by what they make no sense with the answers they put on there. They really need to be watching the video.
Are we promoting a movie?
Oh, sorry. Where was I?
Your foot's starting to jump a little bit. You better get to your next question.
Right. So we're just about to wrap up the school year, and
What are we doing?
oh man, it's late. I got to do a lesson. I got students waiting on me. I'm sorry. I got to run.
Bye.
Oh, cue my intro. All right, let's see. Let's go ahead and get started. It's been 5 minutes. If people ain't made it in now, then we're not waiting any longer. Okay, let's take a look at this week. This is fifth hour. Let's go to our grade screen as usual. We scroll all the way down here past all these other assignments. We are down to 7.03 geometric series. Now, last week we looked at geometric sequences. The week before was the arithmetic sequences and series. We did all those in 1 week, talk about the arithmetic, but now we're in the geometric. And with the geometric, remember, it has a common ratio. So each term is multiplied by the same number to get the next term. So we looked at sequences last week. Series are very, very similar, the geometric series. But remember, just like with arithmetic, sequences was the list of terms. 1, 4, 7, 10, listing the term. Series was when we added them up. 1 plus 4 plus 7 plus 10, So a series is the sum. And we're going to get into that and look at that at 7.03 this week. And we will have some more participation right here off the bat. I'll put the chat window up there where I can see that. See, geometric series lesson. And I think we have some fun little videos, if I remember correctly. I love the little cartoon videos. They just kind of crack me up. Let's see what's going on with this video here. I'll make it big. All right, here we go.
Rachel's mother just returned from a vacation to Moscow. She brought back a set of matryoshka, or nesting dolls, for Rachel. Nesting dolls are a series of dolls that open up so that each doll contains a smaller doll until you get to the smallest, innermost doll. The packaging that came with the dolls notes that there are 8 dolls and each doll is 10% smaller than the previous one. Rachel has a 2-foot-long shelf in her room, but it's covered in small dolls already. She doesn't want to clear it unless she knows the nesting dolls will fit. First, she measures the largest doll. At its widest, it is 5 inches long. Rachel does not want to find 90% of 5 inches, then 90% of that number, and so on 8 times over. So instead, she uses a special way of adding numbers that change by a constant percent. The first doll is 5 inches wide. The next doll is 5 inches times 0.9 because it is 10% smaller. The next doll is 5 inches times 0.9 squared because it is 10% smaller than the previous doll. Rachel can find all of the doll's widths this way. She knows that when a number is multiplied repeatedly by the same constant, the sequence of products is called a geometric sequence. In this lesson, you will see how to add terms quickly in a geometric sequence. This sum is called a geometric series. You can use it to see if the nesting dolls will fit on Rachel's shelf. You find the sum of a geometric series using the formula S sub n equals a sub 1 minus a sub n times r all over 1 minus r. S sub n is the sum up to the nth term. In this case, you want 8 terms added. A sub 1 is the first term, and a sub n is the last term. So here, a sub 1 is 5, and a sub n is 5 times 0.9 to the 7th power. R stands for the common ratio and is the factor that each term is multiplied by. In this case, R is 0.9. So substitute and solve. The dolls will span about 28.5 inches, or just over 2 feet and 4 inches. Rachel's 2-foot shelf is not enough.
All right. Too bad for Rachel. That shelf won't hold. Actually, there's a lot of things that I see wrong with that. First, Rachel's mother was not on a business trip. She went on vacation and left Rachel here. That's just kind of rude. Rachel's mother gets back from vacation in Russia and brings her these dolls. Well, Mom, you should have taken me along. I could have bought my own dolls. That's all right. But, if Rachel really was thinking, she could stagger those smaller dolls and they'd all fit on 24 inches. You can put one little front of the other, behind the other. But not very big. But that kind of shows how the geometric series works. Each one is 0.9 the size of the previous one. And they gave us a formula to use in there. So I've already written that formula on my notes, and we'll get to that in a minute. But let's go on through this page while we're sharing it this way. So we're going to learn how geometric sequences and series differ and what information must be included to find the sum of a series. All right, so here's that participation portion. Let me make this larger. All right, let's let you answer these questions in the chat. We're going to place each list of numbers into the category in which it belongs. So there's only 2 choices. It's either a geometric sequence or it's a geometric series. So that tells us right away that these are all going to be geometric. We don't have to check to see if it's an arithmetic because that's not a choice. The only choice is this a sequence or is this a series? And we're like, okay, what was the difference? Well, remember, a sequence is what we studied last week, where you have 1, 4, 7, 10. But a series is when we're adding them. So with a series, you're going to see a plus sign. So if you see a plus sign, it's a series. So Sean's already jumped on top of this one. He says, well, this is a sequence then, because I see commas. This is a list of numbers. Absolutely. 1, 5, 20. That's a list. What about this one? 4, comma, negative 32, comma, 256. Sean says this is a sequence. Logan agrees. Says absolutely it's a sequence. Sequence. All right, we're hearing sequence a lot here. Just put that as a sequence. How about this one? 3 plus 6 plus 12. Yeah, that's big difference. We can see right off. Okay, we're not just listing numbers. We're adding them together, which is what a series is. And then we have 9 minus 27 plus 28. Wait a minute. I thought you said they added together. Yeah, we're adding negative 27. 9 plus negative 27. So we write that as 9 minus 27. So there you go. Terms are being added. Okay, so now that we can distinguish, let's shrink that back down so we see more of that. Between a sequence and a series, let's discover how the sum of a geometric series without having to add each term to the left, each term to the next. And adding each term could be time consuming. There's a lot. Oh, I do need to make this bigger again because we have another one that we're gonna do definitions. All right, so if we're talking about a sub n, and we can just answer this in the chat with 1, 2, 3, 4, 5. 1, 2, and 3 are on the top row. 4 and 5 are on the second row. When we say a sub n, what are we referring to? So read those 5 choices. 1, 2, 3, 4, 5. And when we say a sub n, is that the first number in the sequence? Is that the common ratio? Is that the sum total of all the numbers? Is that the number of terms or the value of the nth term? Sean believes it may be the value of the nth term, number 5 there. What's someone else think? A sub n, is that the value of the nth term in the sequence? A sub n. Bethany, you think a sub n is the first number in the sequence? Just a guess. Give it a shot. All right. Now we've got 2 different answers. Anyone want to throw in a third answer? Actually, if I gave you all the choices at once, this would probably be easier if you knew what the other 4 things that we're going to define here. Got another one saying 5. We got 2 people saying 5, so let's put this as 5. The a sub n is the value of the nth term. That is correct. Now see, if you'd seen this one before, that might have changed your answer, Bethany, because here's a sub 1. A sub 1, that one we know is the first one in there. If you just saw that as the next choice, you would have known, oh yeah, it's not a sub n, it's a sub 1 is the first number. How about n? What is n? We've already defined 2 of them. 4, Bethany says that's a number of terms. There's n number of terms in the sequence. Taylor agrees. Yeah, there's n number of terms. R, all we got left is the common ratio or the sum total. And R, yeah, we know that's that because arithmetic used the common difference, which was a D. Geometric uses the common ratio. So S sub n, remember the S stands for the sum, adding them all together, the sum total. So you guys did great. You're a lot faster than that than my other Algebra 2 classes. They took a while to figure that one out. All right, so the sum of a geometric series. I'll leave this larger on the screen right now because we're going to have another video here in just a minute. The sum of a geometric series. All right, so let's find the formula. So if we look at this series, 3 plus 6 plus 12 plus 24 plus 48 plus 96. And we look at that and we say, what is the first term? Well, that's real easy. We just look at it and see what is the first one they list. It's a 3. 3 is our first term. What is the common ratio? What's happening each time? 3, 6, 12, 20. Well, obviously it's being multiplied by 2, right? Because that's what it's being. We could divide if we're not sure. 6 divided by 3, that's 2. 12 divided by 6, 24 divided by 12. It's 2. It's being multiplied by 2 each time. So what's the sum? We can find the sum. Let's see. Let's put our calculator up here and say, what's the sum? 3 plus 6 plus 12 plus 24 plus 48 plus 96. It's 189. I just did it in my calculator and said it's 199 if I add all these together. And that's what they have as well. 189 is the sum. So finding the sum of this series is pretty simple. We could just add all those up. It's relatively small. Now they show over here applying the formula. Here is a different formula than they gave us in the video. This uses the first term. A1 minus A1 times R to the nth power. So if we use the same sequence where we know A1 is 3 and we know that R is 2 and N is 1, 2, 3, 4, 5, 6 terms, R to the 6th power. We can substitute that into the formula. 3 minus 3 times 2 to the 6th power over 1 minus R, which is 2. 2 to the 6th power is 64. So 3 times 64 is 192. So we have 3 minus 192 divided by 1 minus 2. So you got negative 189 divided by 1. And again, we come up with the same number that we did with our calculator of 189 using their formula. So that's another formula. So we can look at how the two formulas relate. The one formula just says a sub n. If you know what the sixth term is, which in this case we did, we could go straight to that. And we don't have to substitute this, but there's two different formulas. They're identical because this one is r n minus 1 times r. Well, r is to the first power. So if you have r times r, you can add those together. N minus 1 plus 1 is just r to the n. So you can use either formula. If you already know the term, you jump straight to that. So, all right, let me switch back here. We lost our second video when we switched. Okay, here's our. Let's see what this is. The first term is 3. Factor 3 out of each term. So this is going to do it a little bit different way. So we'll take a look at this. All right, here we go. Oh, yeah, this one doesn't have words. So it's factoring 3 out of each term. So 12 is 3 times 4. 6 is 3 times 2. 24 is 3 times 8. 48 is 3 times 16. 96 is 3 times 32. And we notice those numbers 2, 4, 8, 16, and 32. Those are all factors of 2. That's 2 to the first, 2 squared, 2 to the third. 16 is 2 to the fourth. 32 is 2 to the fifth. So those all can be rewritten as exponentials. So we can see the pattern that's developing there. So now each term can be rewritten using variables. 3 was the first term. 2 was the common ratio. So you got a1 plus a1 times r plus a1 times r squared, etc. So now multiply both sides by the common ratio. So we multiply both sides by r, s of 6 times r, and that times r. All those go up 1. Second power, third power, fourth power, fifth power, sixth power. Now we can take those two equations that we have and subtract the equations. Now that minus means that we have to distribute the negative. So every one of those is going to become a negative. So then we can do our math. A lot of those cancel out. A1R minus A1R. All of them cancel out except the first term and the last term. So now we got S of 6 minus X6R equals A1 times A1R to the sixth. We can factor out the S6. You get 1 minus R. Divide by 1 minus R to get S6 by itself. And that gives us this equation. That the sum of the first 6 terms is the first term minus the first term times R to the 6th power over 1 minus R. So it kind of found how we would derive that equation if we didn't already know it. So in our notes then, we're going to our notes on what a geometric series equation formula can be. There's two ones. If we know what the a sub n terms, because we're summing up the first n terms, like the first 5 terms, the first 10 terms, whatever. If we want to know the sum of the first 10 terms, do we know what the 10th term is? Because we'd use that in this formula. The first term minus the 10th term times the common ratio divided by 1 minus the common ratio. That's if we know what a sub n is. If we don't know what the 10th term is, we can use this formula. The first term minus the first term multiplied by the ratio to the 10th power, if n is 10, divided by 1 minus the ratio. So either one of these will work depending on whether or not we know what the 10th term is. So let's work an example here. Let's just make up a sequence here. Let's say we have the sequence 2, -4, 8, negative 16. Okay, so what do we know about this? We know the first term is 2. And let's say we want to find the sum of the first 15 terms. 15 terms. So we look at it, we say, okay, well, do we know the 15th term? Do we know a sub n? Do we know a sub 15? No, we don't. We only have 4 terms. So we're going to use this formula right over here. So using this formula then, do we know what r is? Well, we can find out what r is. We can just divide backwards. Negative 4 divided by 2. Or we can go this, say 8 divided by negative 4. Or we can say negative 16 divided by 8. But we can see the ratio is negative 2. 2 times negative 2 is negative 4. Negative 4 times negative 2 is positive 8. 8 times negative 2 is negative 16. So that's all we need to know to be able to use this formula. We need to know the r and a sub 1 and the n. And we know the n is 15. So the sum of the first 15 terms, and somebody wants to check us, they can check. Let's see, there's the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term, 11th term, 12th term, 92. All right, and we need one more, negative 16, 384. There, somebody wants to add all this up, you can check us. I'm not going to add those up. I'm going to use this formula. A1, which is 2, the first term, minus A1, oh, that's still 2, times r to the n. R is negative 2, and n is 15. Negative 2 to the 15th power. And that is all being divided by 1 minus r. 1 minus negative 2. All right, let's continue. See. 2 minus 2 times, we need to know negative 2 to the 15th power. So when our handy dandy calculator comes in there, negative 2 raised to the power of 15 is negative 32,768. Okay. Thank you, Mr. Calculator. I'll call you back in a minute. All over 1 minus negative 2. Well, that would be 3. Okay, so now we need to know 2 minus 2 times this. What does all of that equal? All right. Come on back. So 2 minus, and now I'm going to put parentheses, and I'll go 2 times negative, let me put this in there, 768 negative. So 2 minus parentheses, close the parentheses. So 2 times negative 32,768 is 65,536. And it's a negative. And 2 subtract that is 65,538 divided by 3. And this is going to equal, divided by 3. That's what they all equal added up. 21,846. Put it over there too. So if we add up the first 15 terms of this geometric sequence, it equals 21,846 using our formula. If we had to do this by hand, we'd rather do the formula. If you did it by calculator, maybe about the same either way, but either way, it's a pretty good number. 21,846. Okay, here we go. Go to page 2. There's only 2 pages in this lesson, actually. All right. It says find the sum of 5, negative 15, 45. If there's 11, there's 11 terms. So here's the same formula. A1 minus A1 times R to the N over 1 minus R. So you take the 5, which is the first term, and it substitutes everywhere there's an A1, 5, 5. We can see it's being multiplied by negative 3 each time, so that's the common ratio. So where the R's are, R negative 3, underneath in the denominator negative 3, and N is 11 because we want it says if there are 11 terms, find the sum. We want the sum of the first 11. So S11 and R to the 11th power. So they substitute the numbers in, use their calculator, and find out that the first 11 terms add up to be 221,435. Next example here. Oh, I was just looking at this. Wait, looking at my notes. I said there's something wrong there because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is only 14 terms. I didn't add the last term. The last one is 32,768. That equals 21,846. If somebody would have added that up, they would have caught me messing that up. That makes more sense to have a $21,000 positive answer when all these numbers weren't even close to a positive. But when you add that on there, we only had 14 terms instead of 15. I knew something looked wrong about that answer because it's like, how can it equal a 21,000 positive when we got this huge negative 16? Yes, because that wasn't there. That was only 14 terms. All right. Here's an example. It's a video. I'll leave this for you to watch because you can watch the video, but it finds the sum of an 8 term where the first term is 7 and they know the last term now. So they have a video here and it lasts 2.5 minutes and it'll show you how to find the common ratio because we don't know the ratio there, but you can find it out using the other formula because the other formula knows what the last term is. And then the third example they have is you have to figure out which formula to use. If you know the Summer Olympics increases 22% every 4 years and there's 1.5 million viewers in 1980, and that the percentage stays consistent, how many million viewers were there total between 1980 and 2008? Well, since we don't know how many there were in 2008, you don't know the last number in the sequence. So you would not use the one that has A sub n. You'd use the one that uses the first term twice. Excellent. And then ask you then to match what is what. A sub 1 would be the first year, had 1.5 million. R would be the common ratio of 22%, and N would be 8. So, all right. Important note. This is an important note on there. The change will be made only when the common ratio is a percentage. If we're using the formula where it has A1 minus A1 R to the N, in this case, it's saying it increases 22%. We have to think about that and account for an increase. If we just made the common ratio 22%, that means there's only 22% left from the previous year. We have to add it to 1 because we want 122%. We still have all the last time's viewers, plus we've added 22%. So when we're thinking about real life formulas with a percentage like that, we want to add 1.22 to know that we still have everything we had. We just added to it. So that can cause an error in some of your calculations if you don't think about the fact that if you put a number less than 1, that means it shrank. So the number should be larger than 1. So a 22% increase would be 1.22. get into those values. All right, then they let you calculate that and see if you get the right answer. And it'll tell you if you're right or not. So I'll leave that where you can, another example for you to try to see if you understand what it's talking about. All right, and here's applications of that. So Sebastian purchased a mega bouncy ball. Who doesn't love a mega bouncy ball? We could all use a good mega bouncy ball. And it claims it bounces up 83% of its original height. Hey, that's a pretty good bouncy ball. If you drop it from 100 feet, it's going to bounce back to 83 feet in the air. That's a really good bouncy ball. No wonder they call it mega bouncy ball. Sebastian sets up a yardstick and drops the ball from 3 feet. And he compiled his data below. And each time the ball's on its way down is considered a fall. So he drops it the first time and it falls 3 feet. Then it bounces back up to 2.49 and it falls 2.49 feet. And I got to say, Sebastian's a real stud because I could not hold up a yardstick and tell that it was 2.49 feet that it bounced up to. That's pretty impressive. I might say 2.5 feet, but I wouldn't be able to get that 1/100th of a foot measurement. But Sebastian, he's pretty precise. 2.07, 1.72. And he lets it fall 12 more times for a total of 16 drops. And after that, it's too hard to measure accurately, even for Sebastian, who can measure it to 1/100th of a foot right there. So to calculate the total distance fell, he's going to use a geometric series. So let's see what formula he uses. He knows the first term is 3 because that's the first height he dropped it from. He knows that it claims it bounces 83%, and I guess those numbers are 83%. So that's his R is 0.83. And notice we're not going to add this to 1 because it doesn't bounce 3 feet plus 83%. We only get 83% of what the original total was. So he uses this formula, A1 minus A1, R to the N minus 1 minus R, substitutes it in. 3 is R1, 0.83 is the R, 16 is how many times it dropped. So putting all those in, using his calculator, it dropped 16.75 feet over 16 bounces or falls from originally bouncing it and dropping it 3 feet. All right, now it's time to try some on your own. Here's the lesson summary. Like I said, there's only 2 pages to this lesson. It's just, do you understand what the geometric series formula is and can you use it? A1 minus A1 R to the N over 1 minus R, or A1 minus AN times R. If you know the nth term, you don't have to raise R to any kind of exponent. All right, as usual, there's some practice problems here in the lesson where you can do your work and then check it to see if it's right. First one is algebra. Sorry, not algebra. I was going to say definitions, but this is even better. Match the formula to what it is. Which one of those is an arithmetic sequence? Which one's arithmetic series? Which is geometric sequence, geometric series. Now, you got 2 main things you look at to tell, right? First, is it A sub n or is it S sub n? We know S sub n means sum. That means add them all together. So the S sub n's have to be the series. But which one's arithmetic? Which one's geometric? Well, remember, if it's geometric, it uses a common ratio. Well, that doesn't have a common ratio. Oh, that has an R. There's an R common ratio. So if this is the sum and the common ratio, it must be geometric series, which this is the other S sub n. So that's the only other series we have a choice of. Now the sequences. One of them has an R, one of them has a D. Common ratio, common difference. Remember, D was difference, which is arithmetic, geometric. So there you go. And then they give you some more here. If you had to find the 6th term of 2, 12, 22, which one of these formulas would you use? If you had to find the sum of the first 100 terms of 2 plus 4 plus 8 plus 16, which one of these formulas would you use? Find the 40th term of 3, 6, 12. Which one? So this is a great for you to figure out, do I know which formula to even use? Because if you don't know which formula to use, you're going to have a lot of trouble getting the right answer, right? So I'll let you go through this. Okay, so if I did that, nope, incorrect. Okay. The next page gives you more problems to practice with. What's the sum of this geometric sequence? -4, 24, 124. 10 terms. Work that on paper. Check your answer. Did you get the right answer? Looks like it was 34 million something. It's huge. There's 5 problems there. 5 terms of this. Check your answer. 5 problems. All right, let's look at our assignment this week. We have 5 problems. Find the sum of this sequence. 8 terms. So the first 8 terms of that sequence. Find the sum of another 8-term sequence. It tells you when the first term and the last term is. All right, so that one, that other video that we didn't watch, the one you can watch on page 2, will help you do that. 8 terms. Evaluate S5. That means sum, means add those, the first 5 terms for 300, 150, 75, and which one of these. And notice it's going to have a decimal in the answer. Jessa bought a yo-yo from the company that says with each retraction, it'll come up 60% of the original length. So she sets up a tape measure and throws her yo-yo 3 times. 3, 1.8, 1.08. She wants to know after 10 throws, what is the sum? So the first 10, here's 3 terms in the sequence. After 10, what's the total? Add them up. And then here is a graph. The diameter of a bacteria colony that, oh, there's your common ratio, doubles every hour is represented by this graph. What is the diameter of the bacteria after 8 hours? Well, after 0 hours, it's 1. There's your first term. After 1 hour, it's 2. After 2 hours, it's 4. After 3 hours, it's 8. What about 8 hours? So there is your assignment for the week. Geometric series. We won't be doing these arithmetic geometric much longer. I think we've got another lesson after this. Then we'll wrap this up and move on to something else to finish the year. So this is an A-Day Friday, so we will only have a class again on Thursday. If your grade's below 70%, I'll see you then. If you're struggling with this and just want some help, I don't care what your grade is, come on by. We'll do some of this together. And but Thursday is the only other day we have class this week. So have a great week, guys. You got the rest of the hour. You can probably finish this assignment. You got a lot of time. We'll see you next time.